Okay, so continuing on with solubility. So then using our solubility rules that we have from table F, we can get different types of solutions. So we can have a saturated solution, an unsaturated solution, and a supersaturated solution. So again, you should think about writing down these words in red that I give to you on the slide so you have them in your own notes. So a saturated solution is a solution containing the maximum amount of solute that will dissolve in a given or at a given temperature. So again, temperature is the key part in here. Unsaturated solutions are a solution in which more solute can be dissolved at a given temperature, so it's not at its maximum yet. And then a supersaturated solution is a solution that contains more solute than would dissolve in a saturated solution at a given temperature. So it's past its maximum point. Okay, so just some visuals to show you. So again, these might be a good idea to write down. An unsaturated solution, so we would not see any solute left in our solution here when we have an unsaturated solution. A saturated solution is when no more solute will dissolve, so we may see, if we continue to add it in, we may see some of our solute at the bottom of our solution. And then lastly, we have supersaturated solutions, and this is when we continue to add more solute, what's going to happen is this solution becomes very unstable, and unstable meaning crystals are going to start to form. So it won't be that we'll see the solute. What's going to happen is we'll start to react and we'll actually see crystals forming, or this will turn into a completely solid solution. Okay, so then we have table G, and this is solubility curves. This is given to us at standard pressure, which is 101.3 kilopascals, or 1 atmosphere. And then on our y-axis, we have the solubility, and that is the grams of solute. So our grams of solute are here on the y-axis per 100 grams of water, which would be our solvent. And then here we have different temperatures going from 0 degrees Celsius to 100 degrees Celsius. So each line on our line that we have tons of them, but on the line, if our point falls on the line, we are at the maximum amount of substance that can be dissolved at our given temperature. Most of the lines shown that are increasing, those are going to be our solids. And then our three lines that we have here, this one going down, this one going down, and this one going down, those are gases. So if you think back to the first video, remember that solids and liquids increase in solubility with an increase in temperature, whereas gases are the opposite and they decrease in solubility with an increase in temperature. So I'm going to get into an example of how to read this graph, but this is table G, and again, just keeping in mind that if your point falls on any of the lines, that means you are at the maximum amount of solute that can be dissolved at that specific temperature. So for an example, we have point A, B, C, and D here, and this is just one of the lines just to kind of zone in on one example of this. So again, the line tells us the maximum solubility, and then we're going to look at each point and what that means. So if we look here at point A, it's approximately 35 degrees Celsius, and I would say 25 grams of our solute. This is below our line here, so it's below that maximum line of solubility, making it unsaturated, meaning we can add more of our solutes at this given temperature to make our solution saturated. So we can add going from 25 grams of solute all the way up to, let's say, 55 grams at this temperature to get to our saturated solution, which leads me to point B. Point B is on our maximum line. So this, because it's at a maximum, is going to be considered saturated at this temperature of, I would say, about 35 degrees Celsius and dissolving in 55 grams of our solute. Then if we move to point C, it's still on our line of maximum solubility, but it's at a lower temperature, so it's at about 20 degrees Celsius. So we notice as we move down and decrease our temperature, our solubility is going to decrease. So less solute is going to be able to dissolve into our solvent, which we see we're going from 35 degrees Celsius and 55 grams all the way down to 20 degrees Celsius and 35 grams. But because it's on this maximum line of solubility, it's still considered to be saturated. And then we move to point D, which is above our line of maximum solubility. So this is saying at 20 degrees Celsius instead of at point C, where we're only dissolving in 35 grams of solute, we're trying to dissolve 55 grams of solute. And we are not going to see this happen. We will see a supersaturated solution. So going back to our picture, we will start to see some crystals forming if we try to dissolve that much of D into our solvent. And that is how you read these graphs. So anything below our line, given the data in a problem, anything below our maximum solubility line is going to be unsaturated. Any point found on the line is going to be saturated, and any point found above the line is going to be supersaturated.